Okay, now let's come back to this problem because we discovered that we are going to possibly have some fractions involved. So we started to do this using substitution. We first got y by itself, we substituted it into the second one, we distributed, we got here. Now we want to combine our like terms, so how many x's do we have altogether? 7x minus 20 equals negative 12. We want to get 7x by itself, so I'm going to add 20 to both sides, right? 7x equals, what does it equal to? 8. Now we divide by 7. We get x equals 8/7. And a lot of you were like, it must be wrong. That can't be the right answer. But this is one of the reasons why we have the substitution method, is because if we graphed these, we would not be able to tell what the point of intersection is, unless we used like a scale of sevenths. Who does that? Barely anyone. Okay. So now, here's actually the trick that I was going to show you before too. When I do my check, I'm actually going to solve for y at the same time. So I'm going to go 2 times, in the first equation, 2 times 8/7 plus 2y equals 10. Okay, so I'm going to solve for y, and then that's also going to count as my check because I'm going to do it in this next problem as well. So fractions. Well, we could use a calculator here too. But let's work with the fractions because we do need to know how to work with fractions. So when we multiply, do we have to have a common denominator? No. We just multiply across. So we get 16/7. Are you with me? Plus 2y equals 10. Now I want to get y by itself. I'm solving for y. So I'm going to subtract 16/7. And the thing is that when I add fractions, do I need a common denominator? What would be the common denominator? 10 is equal to what over 7? 70/7. Are you following what I'm doing here? 70/7 is equal to 10, right? Because 10 over 1 times 7 over 7 equals 70/7. It'd be nice if the fractions were a little bit friendlier. 2y equals 70/7 minus 16/7. What's that? 2/4. Am I doing this right? It's not. Tell me. Okay. And now what do I do? Yes, or multiply by 1/2, the reciprocal. Divide by 2 is the same thing as multiply by 1/2. Does everybody know that? Divide by 2 means multiply by 1/2. So these cancel. We have y by itself. Oh, half of 54 is 27. That's where you got the 27/7, right? Because this cross cancels. 2 into 54, 27. 27/7. I only just knew the 27/7 was the answer because someone told me. A little bird told me. But here's the thing. If you want to check, let me show you how you could actually check this. Now that I have both answers, okay, and we're going to state the solution. The solution is 8/7, 27/7. And I'm going to do the check in equation number 2. So I checked here, number 1. If I get the same thing, I mean, I would be basically putting these answers back in. You could do that. You could put them back in. But let's just go in the second equation. So let's remind ourselves, there's a second equation. So I'm going to do this check. 3 times, what was x? 8/7? Minus 4 times, I'm just writing it really weird because I don't know. Are you keeping up with me? It's just the -4. I just put it in parentheses for no reason. Just for multiplying reasons. Okay? Equals -12. You could do all that math, and actually there's a common denominator, so it's really not that bad. But I'm just going to show you how you could plug this in on your calculator as well. So if you have a basic calculator, you can plug in fractions because fractions are just division problems. So we have 3 times 8 divided by 7 minus 4 times 27 divided by 7. Do you see how easy that is to put a fraction in your calculator? Enter negative 12. Okay? So negative 12 equals negative 12. I use the calculator. But what somebody else discovered is if you have 8 divided by 7 and you round that off, your check is not going to work if you use the decimal. So realistically, the decimal is okay in certain situations, like, oh, I really want to know that I have $1.14 approximately, I have 8/7 of a dollar. Who says that? Nobody. But the fraction is always going to be more exact if it's a repeating decimal, because any seventh is going to be a repeating decimal, unless it's like 49/7. That's 7. You know what I mean? Okay. Any questions about that? So I have my sentence written here. The solution is I'm doing check number 1. To do check number 1, I have X, I'm finding Y. I'm assuming that works, because that's what I solved. If it turns out that my second check doesn't work, what does that mean about my solution? It means it's right. It's not right. You're right. It means it's wrong. Exactly. It's not right. It's wrong. Whatever we want to say, however we want to say it. I was tutoring a kid the other day, and she said, "I am not going to not do that homework." I was like, "Great." And then she had to add in a third not. I am not going to not do that homework. What's that? Oh. Okay, let's come back to it in just a second, okay? Okay, let's push forward here. We have y equals negative 3x plus 3. What are we going to do with this? We already have it ready to substitute, right? So let's plug this in for y. 3x minus 3x plus 3. I don't have to use parentheses because I don't have to use the distributive property because that's just a 1y equals negative 5. What happens to my 3x's? Oh, 3x minus 3x is how many x's? 0 x's. So the x's cancel out. Now what we have left is 3 equals negative 5. Do you remember that from Math 60? What does that mean? There's no solution. There's no solution because 3 is not equal to negative 5. That's a false statement. So there is no solution. What do you think is true about these two lines? They must be what kind of lines? Parallel. And parallel lines have what kind of slope? Parallel, same slope. Is there anything I could do to check and make sure both of these lines have the same slope? Exactly. If I put this in y equals mx plus b, your favorite form, slope y-intercept form, by subtracting 3x from both sides, I can prove that the slopes are the same and the y-intercepts are different. Do you see that? They both have a slope of what? Negative 3. Do they have the same y-intercept? No. So they're two different lines. They're parallel to each other. They look something like this, right? They have negative slopes. Here's positive 3. Here's negative 5. Okay, that's just a rough sketch. Don't count that as a graph. That's a terrible graph. But you get the idea. They both have the same slope. Therefore, there's no solution. So what I would say you need to do is check the slopes. If you're not sure if it's right or wrong, check the slopes by putting them both in slope y-intercept form. Does that make sense? How you could check that? Awesome. Okay, let's try this one now. 9x minus 3. What am I substituting in for y? 3x minus 4 equals 12. Okay, and what should I do to solve this one now? Yeah, I want to distribute. So I get 9x. What do I get next? Tell me. Minus 9x plus 12 equals 12. Now what should I do to keep solving? Oh, what's 9x minus 9x? Again, 0x. Now, this is one where a lot of people will get confused and they'll put x. But if you have 0x, anything times 0 equals 0. 0x is 0. So you just get 12 equals 12. What do we remember from Math 60 when we have no more variable, but we have a true statement? Is 12 equal to 12? Yes. So what do you think is true here? Okay, now this is a difference. It's actually not necessarily all real numbers. It's every ordered pair on the line. So you do have a number, you have an infinite solutions, but there's solutions x such that, no, actually, sorry, the xy such that they belong to y equals 3x minus 4. Basically what that says is all the ordered pairs that are on this line are solutions to the system. Because if you say all real numbers, that would mean every single ordered pair that exists, but every single ordered pair that exists doesn't exist on one line. You know what I mean? But how could we check to make sure that these really are the same line? Because if it is infinite amount of solutions, that means that they're the same line, right? So how could I prove that? What do you think? What would you do? Oh, solve for y, right? Solve for y. So we would want to check by solving for y. So 9x minus 3y equals 12. I want to get y by itself there. So what would I do? Negative 3y equals negative 9x plus 12. Divide by negative 3. That's important because that's where I see a lot of mistakes too. People will forget that negative sign. Y equals, what does it equal to? 3x minus 4, which is the same exact equation. So we proved that they're the same line, and since they're the same line, they really do have the same equation. So I think this is the formal way of writing it. It's basically set notation, set builder notation, saying that all the solutions x, y on the line, basically, that exists. Every solution that's on the line is a solution because they're the same lines. But you see the difference between saying all real numbers and infinite amount of solutions? It's kind of like a little bit mincing words there.